Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day. We are in chapter number 5, Geological Structure. What is geological structure? Geological structure is study of the three-dimensional distribution of rock with respect to their deformation history. Deformation history. So, mean that this is a study about how this rock change throughout the geological time scale. They use measurement of present-day rock geometry to obtain the information of the history of rocks, and then we want to understand the stress field that shape in the observed structural geology. So this is our geological structure. For example, this is bedding plane. Bedding plane is one of the structures geology. You see the flat structure. This is our scale. So what happens if we have stress here? So this flattened bedding will be changed, can be shaped due to this stress. So this example of the bedding planes, you see like this, overturned like this. So this how originally is in the flat conditions. So this why we study this, because we have to know this distribution of that the rocks with respect to deformation history. So this is the important what's the use of and importance of this study is structural geology. Structural geology is another term that we are discussing in lab number 4, which is we classify as discontinuities. This we also classify as more general is structural geology, which is internal weakness of rocks mass that will affect the stability of engineered structure. So for example here, structural geology to understand the ground flow. So if you want to understand the ground flow and penetrations of water, so you have to understand the geological structure, how the geological structure looks like. Or you want to understand the seepage of toxic because of this ground flow. So salt water in seeping into the aquifer, also you have to understand the geological model and also seepage of them. The importance of this geological structure, you want to understand the geological model of the rock mass. So it's similar to the weathering. When you study weathering and the geological structure, the outcome of this study is to understand the model of subsurface of the ground. Okay, for example, like this is sedimentary rock. This is the ground's model looks like. See how this model looks like. So see this bending of this layer of sedimentary rocks. So you can see this is another fault line. Also see this rock looks this layer. So we find another layer here, similar layer, because of this fault line. You can see fault line here. We have another fault line here. So here, okay, this is sedimentary rocks. So you can see this. So because of that faults make this our ground model is looks like here, like this. Yeah. See this, you can see this is rock, this is soil. So this is model of this ground. This is weathering profile of this material. Quite not very thick, so This is not a tropical country. You see the bushes here is quite not very thick. So for introduction, how this geological structure form, this is because of this our earth crust is mobile. The mobilization is like divergent, convergent, transform, uh, like we are discussed in chapter number 1. So this movement will create force, okay? Force that will maybe in the form of collision, or compression, tensional, and shearing. Then it will result the rock will change shape. For example, like this is in uniform, so the direction of force in all direction is similar, so in confined space. But if we have higher force on the y directions compared to x direction, so this we call it tension force. So the shape change in these directions. If our similar like our mobilization of the force in this opposite in the similar directions, so we have compression, collision, and then if we have this in y x direction is higher than y direction, so we have shear. So shear is higher, so we change the shape. So compression is the compress of body in convergence, tension in rock pulling apart, okay, is divergence, shear is force acting parallel in but in opposite direction. So this is the geological form based on the force created in the tectonic event. So what is another deformation in rock? So to understand that, so we have mode of deformation, we call that brittle, which is rock simply break like this. Is brittle. This is intentional force, so we have break here, so this is called brittle. So another mode of failure, called the mode of failure, mode of deformation. So you can see that mode of failure, which is this is a ductile uh, mode of failure, which is the rock deform. So in case like this, so normally, so this part change their form because of that tensional force. So this is intentional force. So imagine if we have in compressional direction. So if we have uh, ductile deformation, means this rock will be deformed like this, bulging like this, bulging. So if we have force like this is rock like this. So if in brittle, so this rock will feel like shear, or shear like this, or break like this. Okay, or break like here. So can break here. Okay, so this is simply break. But this one we change the shape. That's why it's brittle. Okay, so this is how this rocks mode deform. Okay, deformation mode. So the factor that control the mode of deformation, rock deformation, even in soil, which is the confining pressure, temperature, and speed. So this is how the material behave in the brittle material. If you have apply of stress, increase in stress, so we have strain, deformation. Strain is deformation. Another word for deformation is strain. So they will have strain. So keep in linear. So when we increase the stress, our strain is also increase. So after a certain level, so our failure happens here. So suddenly it's fail. So for that brittle. But in the case we have a ductile material, we don't have any sudden failure like this. What happens is when we apply stress, the strain deformation is keep continuing occur until it's flattened like this. It's normally if we shape our compression stress, so the shape of our sample maybe like this, become shorter and bulk and call that bulging. Okay, so this is confining pressure, temperature. So when we discuss on confining pressure and temperature, rock behave brittle when we are near the surface. So mean that the confining pressure is low, and also the temperature is low, relatively low. So the rock will behave brittle. So if we have a ductile, so rock will behave ductile when our confining pressure is very high, is in deep, and when we have in deep, our very deep, so our temperature is very high, so the rock will behave ductile. So although when we discuss on speed, when we have discussed on tectonic event, so the speed of this plate movement of discussed on centimeter per year. That's how we imagine the speed. So the rock will behave brittle when we apply stress rapidly, and then rock will respond ductile if our stress is slowly, if we apply slowly. So the behavior is depend on this factor, three factors. So